research and in the past has switched from one to another. And I wanted today to talk a little bit about my experience of this switching and some cultural differences that I observed in professional software engineering and software engineering in research. That all started some 12, 13 years ago when while still working at the industry, I decided to go a little bit back to my research roots and together with a couple of PIs from some universities, we decided to make a software package on evolutionary genetics. And I was pleasantly surprised that communication with these people was much smoother and easier than communication with industry users. 10 years ago, in September 2010, I presented my observations at a Java 1 conference in San Francisco, talking about what it feels like working together with researchers compared to, again, my experience in the industry. So today my talk is kind of follow up on that talk 2 years ago, because in these 10 years, I worked much more with researchers, and I guess I understand much more about really the cultural differences that we have. So let's start with what we have in the industry. A typical start of a software project in the industry is like this. You're talking to a stakeholder who has money and will pay for the project in the industry, who is a well-known businessman or a top manager. And he has a vision like, we need this application that will have a large button in the middle of the screen. And yes, this application absolutely need to use something which is currently in fashion, like blockchains and deep learning. And you're really confused. Come on, but what the application should do? And the response is like, yeah, when the user clicks on the button, the screen should start blinking. You're even more confused. And the only solution is you call on the army of marketing researchers, product managers, software architects who try to fit all the pieces of the puzzle together and try to understand what is really we need to do. And that really kind of agile way of working, as it's called now. But if you think why this happens in the industry, in my opinion, the answer is relatively simple. I can illustrate what happens using this picture from Peter Bruegel the Elder. Suppose that you want to ask an artist to make a copy of this painting, but the artist never has seen this painting. And you have the only old rotary phone by means of which you can explain what the painting should contain. So you try to put it in the words and sentences, and that's an extremely difficult task. That kind of illustrates the disparity between the visual language, because looking at this picture, you get pretty good impression of what is there, and verbal language. And this translation is a very difficult task, and that's why you need this army of people to really make a translation and to explain the engineers to what they do. And it happens that talking to researchers is much easier, in fact. Thinking about why, I would say that the main reason is that researchers approach creating a software package as planning an experiment, and they're well versed in planning experiments. They know how to do it. They also have a lot of experience writing some grant applications. And again, they know they have to put all the details about what they're going to do in these grant applications. Finally, Most of them teach students and also experienced in explaining and making themselves understood and understand what other people are saying. So that makes you still probably as a software engineer talk a different language than evolutionary geneticist, but it's more like a German and Portuguese speaking people. If they have sufficient incentive to be understood by each other, they can do it using dictionaries or today using a Google Translate. So that's kind of a perks of that I see, the cultural difference that makes our life easier. Now I'm coming to more differences that um maybe a little bit more controversial. So I was working about 20 years in the industry before I went back to research, and uh, one of my managers, a top manager of one of the companies whom I worked, and really my mentor, always taught me that in the industry, the main thing for a project is to have a vision where you will be in maybe 2, 3, or even 5 years. And it's okay to use your aspiration, and nobody really cares about what you have done. One of the mistakes that people make in industry, talking about how much they have done in the past, and people who can pay for their new projects just do not care about it. They care about what they what we want to do, our aspirations. And if we fail in our aspirations, it's okay. As Jeff Bezos, the founder of Amazon, put it, there's some failures in the industry that are perfectly fine. If you try to do something new and fail, that's okay. You will have a next try to do it. It's really different in research, I guess, because failing on the grant is really a small catastrophe. It's not really acceptable for researchers. So, recollecting my dialogue with one well-known scientist, when he was telling me, Misha, does this software package really work? Is it already working, or you still need to do something? Have you validated all the results? How many users we have now? We cannot discuss it with anybody uh, before we're really sure that it's perfect and flawless. Otherwise, his reputation will be in danger, and that's one of the most important things for him. So aspirations do not really work here. And to illustrate it further, I think this anecdote that the same scientist basically told his postdocs and students, I think is really very illustrative. He was recollecting his experience talking to a lady who was contending for a role of CEO of a fairly large company in our Boston area, affiliated with the university. So university professors have been invited to the talk. And her points was very simple. First, she told that, yeah, we all know that we need to change a business model in this company. And a similar change to the business model has been done in the past somewhere on the other side of the globe in Japan or some other country nearby. So we know that it can be done. And I have done some changes of the business process, not this one, but different kind of changes in the past. So I'm capable of doing changes to business process. Therefore, I will change your business process and we will be successful. And she got a job. She was reasonably successful in what she has done. Nowadays, she has moved forward to even higher positions. But the scientist was stunned. He was kind of saying, yeah, if I were interviewing postdocs for this position and they would talk to me like that, that would be the last time I have seen them. So that really underlines the differences in the vision. The other area where I think it's very different between uh, how industry and research area works is that from mid 80s There's a 90-90 rule, which says that the first 90% of the code accounts for the first 90% of the development time. The remaining 10% of the code accounts for the other 90% of the development time. Well, it was in mid-80s. Nowadays, I think a more familiar statement is that last 10% of the software project takes 90% of the time. At least it adds up to 100. But yeah, that's because beside code, there's also testing, documentation, debugging, what's not. Unfortunately, this message is hard to swallow for many researchers, at least those with whom I worked. If I tell them that I'm really close to completion with the project, I'm almost done. I try never to use this word almost, but well, to say, yeah, I'm close to completion. They assume that this means that the next day, or at worst, the day after next, I can devote 100% of my time to working on a different project. And if in, let's say, a couple of months, I will tell them that I have to debug some issue in my code of the project that I completed a couple of months ago, they would be really furious and say, well, that means that your code didn't work. You didn't do a good job. Actually, they know that this rule applies to their own work when they try to publish their results. But for some reason, they deny us the benefit of being in the same boat. And again, that's something that we have to deal in when we work with researchers. Finally, my observation is that for some reason, people in the industry are much more open to new technologies. Uh, Illustrating it, but this famous Gartner curves of hype cycle for a technology, it looks like most programmers in the industry really would like want to work with the technology that is on the peak of the hype cycle. That certainly might not be wise, but it has some advantages because these people are open to new technologies. They're ready to invest their time, or maybe it's not quite their time because it's paid time, but still they are eager to invest it in learning something new, and they're eager to try to apply other technologies in the work they have done. Here is a list of just a few technologies that at some point was the most fashionable and mostly talked on technologies, and everybody wanted to do it. Like 5 years ago, all graduates from computer science wanted to program in Go, and then they wanted to use Spark, and then nowadays it's more like TensorFlow and AI. It's different in research, at least in my experience. Try to convince a grad student, non-computer science grad student, to write their code in Go, or even create a summary tables using MDX and not vanilla SQL. It will be different. Well, Go might be too niche for them, but what about Julia? Everybody tells me that Julia is much superior for scientific programming than either Python or R, but I don't see a widespread adoption of it. Even using containers make people raise their eyebrows, and I had difficulties 3 years ago convincing people that we have to switch to some containerization, and their concern was not security, it was really performance, which non-existent concern here. I guess again, it's understandable because people in academia want to focus on their science. They don't want to be distracted by some new technologies that may be fashionable. It's good, but it has those drawbacks that they're maybe too conservative. I just wanted to uh, give an example of at least 3 technologies that I really think deserve wider adoption outside of their primary areas. If you are not coming from genomics, you probably didn't hear about BG zip utility. In fact, it's an awesome utility. It uses standard GNU-zip format and completely compatible with GNU-zip. It can read and write GNU-zip files, and standard GNU-zip can read files created by BGZip. But it also has an ability, when it creates an archive, it creates an index inside an archive that allows direct access in the middle of the file using a line number, which is extremely useful when you deal with huge CSV files. That's why it comes from genomics, but it also can be used in other areas. Also, in genomics, workflow languages are very popular. Most of us write some scientific workflow, but we don't use workflow languages. I also needed some effort to convince people that workflow has been put into a formal language. Finally, multidimensional cubes are widely used in business intelligence, sales forecasting, financial industry, but they're not used in research. Believe me, they're very useful for visualization of data and getting some insights from the data. So with this, I want to make a short conclusion, basically, that benefits of being a research engineer come at a cost. I really value these benefits, but let's face it, for a new graduate student, it might be a shock to be in research environment, especially if the internship was in a company like Google and Amazon. And with this, thank you very much for listening to me.
Thank you, Michelle, for a very interesting talk. Unfortunately, we are at the time limit, so we won't have time to take any questions, but maybe people can ask the questions in the chat. And
yes, of course, I will be happy to answer anything that is asked.
And we will move on to our next speaker, which is Benjamin Sims. Are you here? There you are.
I'm here.
Great. So you may share your slides. His talk is titled Research Software Engineering as an Emerging Profession, a Sociological Perspective. And Benjamin is from Los Alamos National Laboratory, and he is a research software adjacent social scientist.
All right, thanks for that introduction. So the first thing I want to mention is I have sort of tweaked the title of my talk. I'm now calling it Research Software Engineer as an Emergent Professional Identity, which just reflects a focus because I tried to make it shorter and I had to cut a bunch of things that related more broadly to the profession. So this talk is based on a sociological study I'm doing on research software engineering as an emerging profession. Yeah, and I've changed the title to focus more on the identity issues and the findings from the interviews rather than sort of a bunch of sociological theory. So my motivation for doing this study was first, my experience. I work a lot with RSEs, or people who could be called, research software engineers. And so I'm very interested, and I enjoy working with those folks. And then that made me curious, like, this is an important new role, and the way this study is funded is because trying to answer the question, what can we do to actually support it better? And for me personally, as a sociologist, I'm just interested in looking at how sort of a new professional identity takes off like this. And so my goals with this talk are to feed back what I've learned from talking to research software engineers back to the community, and check if my interpretations are right, and sort of point in the direction of how they might be relevant to US-RSE and other organizations thinking about the future of research software engineering. And so the main things I'm going to cover are overlap between and I'm just going to use the abbreviation RSE throughout the talk. So overlap between RSE and other roles, models of RSE identity, and RSEs at national labs. So I'm going to skip through this very quickly. the basic gist of this is there are lots of professional identities and kind of overlapping and vaguely defined in computing in general. And so research software engineering or any kind of new role in computing is going to have some issues with like, where do we actually sit in this kind of set of kind of vague different kinds of roles and titles. And in a context like that, I think it's helpful to pay close attention to the way people connect with the RSE role and identity. In particular, there's this thing that keeps coming up as to whether software, research software engineers are people who focus narrowly on working closely with members of a research team, or is it more broadly inclusive of all software practice that advances research? And maybe it includes both, but people have sort of different ways of approaching that. So I'm going to go talk about the interviews now. And I'm going to blow through this very quickly as well. I talked to 17 people who meet sort of the broad criteria of a research software engineer, but deliberately pick people so not all of them actually identified as research software engineers, because trying to get at why people might choose to or not. And so there's a lot of caveats with sort of a small, relatively informal study. But in any case, so here's some information on professional identities in my interview subjects. So if you look on the left here, you'll see, first of all, that I talked to mainly national lab people rather than university people. I talked to a few people at universities. And there's basically three categories of people here. There's people who say, I'm an RSE and nothing else. And then there's people who say, well, I'm an RSE and something else. And then there's actually a larger group of people who I interviewed at national labs who said, I'm not a research software engineer, even though they seem to fit that kind of mold. Of the people who said they weren't, 3 of them had never heard of the role, and 5 of them had heard of it, but just didn't think it fit them. So one thing you can do is you can look at, if you look on the right side here, people identified as RSE and something else. That something else was most often software engineer. And if you look at the people who did not identify as RSE at all, their main roles they described as either computer scientist or other scientific computing, which is a lot of kind of HPC professionals in this case. And so that's sort of, that does suggest there's a lot of, there may be a lot more overlap between RSE type identity and just software engineering in general, where there might be a little bit more of a harder or more difficult boundary to cross between RSE and computer science or certain HPC roles. So now I'm going to talk briefly about what I call models of RSE identity. And these are the kind of ways that people expressed their connection to the role in interviews. And some of them are more identity-based models, which are just, they're not really concerned about, what is the boundaries or, what does a research software engineer do exactly? It's just people who feel very strongly that they identify with the role. Or people who also feel very strongly about not identifying with the role, often because they view themselves as more of a scientist. And then there's boundary-based models, which where people are kind of trying to break things down a little more precisely and say, this is what a research software engineer does. Well, and it's different than what a software engineer does or a DevOps engineer, even if they're all related to research. And so this sort of, I've jokingly kind of described the chameleon model, where people will say, well, at the beginning of the project, I was a computer scientist, then I was a research software engineer, and then I'm a DevOps engineer, but I'm starting a new project where I'll be a research software engineer. Or just kind of saying, I'm 20% a research software engineer and 80% a software engineer. And then people who knew about research software engineering and kind of drew a boundary that was, I am not in this role, like, because I do mostly DevOps or things like that. And then, of course, there are the people who never heard of it. And there's ways that these identity models may shape engagement, I think. This is all very tentative, and I'd like feedback on this. It may be that people who adopt identity-based models may be seeking organizations like US-RSE as a way of primarily kind of just getting together with like-minded people and building sort of a common identity. And the people who are sort of breaking things down more in the boundaries are focused more on the tasks they do as a RSE and so might be more interested in, kind of knowledge and best practices and training and things like that from these activities. And so you may think about how these might apply to you or other people you know. And then getting to what I found about research software engineers at national labs, there tends to be, I think sometimes people think of it as being kind of a monolithic community, and it really isn't. For example, like in this workshop, we see a lot of people from national labs who work in dedicated research software engineering organizations like Sandia and Oak Ridge. And so there's probably not a lot that needs to be done to connect with those people. But then there's the people who work in more HPC-oriented organizations who may more commonly be PhD computer scientists or other scientists who kind of transitioned over into high-performance computing roles. And there's these status distinctions in that community that incentivize some people to identify as a scientist rather than an RSE or a software engineer. So the software professionals are highly valued, but they might lack clear career paths there. And then I seen at Los Alamos, and this is a hard group of people to find, so they may exist at other places as well. People are still kind of isolated, and they often work in organizations that place a little less value on computing skills, that aren't HPC oriented. They may more often have bachelor's or master's degrees, and those folks often seem really blocked in their career advancement, and less aware of the RSE role. And so just going through again how this might shape engagement probably doesn't, probably people who are in RSE organizations are already sort of aware of US-RSE and the whole role. People in HPC-oriented organizations are going to be a challenge because of these sort of status distinctions that they are really concerned about. And so some people may not want to be seen as an RSE, even though they do that kind of work. And then these isolated people are, I think, very hard to reach potentially, but might really benefit and be interested in organizations like US-RSE. And so I'm going to leave it there, just reviewing that professional identity is kind of a big deal when you're trying to put together a new role like RSE. And so it's important to look at things like, do people take a more identity-based approach or a more boundary or task-based perspective, and also consider the different communities exist out there, especially in national labs. So I hope we'll have some time for a couple of questions, but if you don't get one in, you can look me up on the US-RSE Slack or send me an email. Thanks.
Great. Thank you, Benjamin. Questions, anyone? I know there was one from Patrick earlier. Do you want to ask a question? If not, I can read it from the chat.
Yeah, sure, I can ask it. Yeah, so I'm in your survey, you didn't have any of the RSCs co-identifying with being researchers or research scientists, and I was surprised by that because I'm personally somebody that is maybe an RSE and maybe a researcher or research scientist as well. So, are there RSCs that co-identify that way?
I did not encounter. I don't think any of the people I talked to did identify that way, and I'm trying to think: did I select them out somehow, or? But it may be that that's another issue, like especially since I was talking to national lab people, where I don't know, people who are scientists have this sort of phobia of being identified as engineers, so they really emphasize the science role.
My job title is Land Surface Processes Computational Scientist.
Uh-huh.
But I work side by side with people who are bona fide RSEs, and I might consider myself as partly an RSE, but I don't think I'm entirely an RSE.
Out of curiosity, are you at a national lab or?
No, I'm at the University of Reading in the UK.
Okay, yeah, I wonder if that might be a difference there.
But I should say that I'm also at the National Center for Atmospheric Science at the University of Reading, which is kind of like a national laboratory.
Okay. Yeah, I should look into seeing if I can identify people like that.
Okay.
Right. Then we have Rachel, who has a question.
Yeah, thanks for a really interesting talk. If this data set continues to grow, I'll certainly be curious to see what other trends show up or if these ones hold up. One thing I was curious about related to sort of willingness or perhaps hesitancy to adopt an identity. Did you collect information on people's backgrounds, like what fields their degrees were in, and to see if there's any correlation there? Because I could imagine if you don't have some sort of degree in a explicitly computing oriented field, that could contribute to hesitancy perhaps.
Yeah, I did collect that data, and I don't remember exactly how I even had a graph of it at one point in the talk. I don't remember exactly how that works out. And it was, but just talking generally about people's backgrounds where I interviewed, it was some variety. And there were people who were had once considered themselves domain scientists or engineers other than software engineers or other roles like that. So there's certainly not a one-to-one kind of mapping between background and identity there.
All right, and then one last question in terms of time from Rinku. Hope I pronounced your name right.
Yeah, that's right. I didn't have a question, but I did have a comment on what Benjamin said about scientists having phobia about being, when asked to relate to RSEs. I do think a lot of scientists do have a phobia because for whatever reason, the RSE track is a little bit more ambiguous than the scientist track, and therefore gives the perception that it's junior to the scientist track. So, I think I've noticed that too, that a lot of scientists, assistant scientists that I work with relate to more being a scientist rather than being an RSE, even though the work they do might be 90% RSE. RSEs somehow don't seem to carry the same prestige that the word scientist carries. And I'm hoping that we can change this in the future by more awareness.
Yeah, that's a great comment. And I think that, it might be related to the fact, this kind of thing where a lot of times grad students come in and are expected to do research software engineering work before they move on to become, a scientist. And so there's this there may be some sort of assumptions built into that, that, RSE is not, at that level, which is exactly what I think the RSE movement is trying to push against.
All right, great. Thank you very much. There are a few more questions in the chat, if you want to answer them, that we didn't have time to get to. And then we'll move on to the next candidate. By the way, from now on, I hope it's visible. So if the speakers from time to time look at me, I will hold up a note when there are 3 minutes left before we reach the time limit. All right, so the next speaker will be our very own Sandra Giesing from the University of Notre Dame. And she is looking forward to a summer with socializing with people in 3D and not only with people in squares on her screen. And her talk is Press Qt Services, a path forward for connecting platforms for increasing quality and fairness of data and software. Take it away.
Thank you very much, Julia. And yeah, so Press Qt Service, the preservation quality tool, is really about preservation of artifacts. Therefore, Indiana Jones is very well fitting here. We want to preserve and rescue knowledge and artifacts. So the preservation quality tool is about bridging the gap to data and software sharing. And researchers, even though the situation is already better with tools and more tools are available, are still in the situation that it's hard to have all the data and software always preserved at the right level and at the right time of a project. And libraries, so my co-PIs are all from the libraries, and they are like, okay, normally they come to us at the end of a project instead of in between. And then it's a really hard step. So if you look at projects, of research projects, you have a new project, you select or develop tools, and there's this data assembling or creating, write reports, and then at the end it's like, oh, the funding ends, we have to, you know, preserve the data and the software. And it would be much easier from the beginning if there would be the step of assuring the quality of data and already from the beginning and at the end, then it should be an easy step to have the final data and software really before the funding ends preserved. And it's also, there are pressures from the outside, not only from the White House, but also from funding bodies. So it's a good step to work on it. And when I talk about fairness, I think everyone probably thought that already. I really talk about the FAIR principles: findable, accessible, interoperable, and reusable. And that is what we are working on. So if you look at the research data management archipelago, yes, there are a lot of islands, isolated solutions already, but PresQT looks really at connecting these different fantastic solutions. So that's the idea behind PresQT, and it's a collaborative effort. So we had first a planning grant, and the implementation grant was really about collaboratively design, develop, and connect interoperable and repository agnostic data and software preservation quality tools. What does that mean? So we invited a lot of partners who have really a lot of stakeholders and get the opinion from different ones. So you see funded sub-awardees, libraries, the Hub0 team, National Data Service. Then we had collaborators and testing partners from different libraries, but also ReproSep, Jupyter, CERN, and organizations and activities from Midwest Big Data Hub, the Science Gateways Community Institute, URSE. And we had workshops on different aspects, for example, with Mark Wilkinson, who is the first author of the FAIR principle paper from 2016. And he worked with on the FAIR testing part of the work, as well as Daniel Clark and Avi Mayan with their FAIR testing tool. So we started really with inviting stakeholders to surveys. We had over 1,100 answers on the surveys, 1,700 answers. We had different workshops, and we started to with the tool design. And then we really did open source tool design with the community. And we also considered really the workflow of a researcher. They ask themselves if really for the use of technology, that is the process. If I use something new, will it help my job performance? Is it useful for my work? Is it better than the old way I do? Is it easy to use, easy to learn, time consuming, efficient? Can I do this? Does it fit my knowledge? Does it fit with my work style? So these are the normal questions researchers have normally. And so the concept was that we are not developing a new standalone solution, but that we connect the partner systems and services, and that they are easily integratable with RESTful APIs and services. And it was a user-centered open design from the beginning and a collaborative development. And we are next month at the end of the implementation period. So what we connected already and enhanced with metadata is PresQT is a set of web services and has a RESTful API. And you can upload, download, transfer between these different systems. So for example, between Zenodo and the Open Science Framework, CurateID is a preservation system at Notre Dame, GitHub, Figshare, GitLab. You can connect us all with PresQT services. And if you are, for example, a user of a science gateway like the Open Science Framework or Hub0 or Hotel, you can connect and then transfer between the different systems. We have also integrated services. And fair shake and fair sharing, that's really a fair assessment and a fair testing. SciGraph is for keyword enhancement. So we are using this service. So if people or users have already, for example, keywords or tags, they can enhance them automatically with SciGraph. Easy is also a very interesting service. It's emulation as a service. And Easy looks, for example, if you use files like, let's say you created some at the beginning of the 90s on a Windows computer, and you cannot open them anymore, and it's an Excel spreadsheet, for example. So Easy can emulate that, and you can open it again and save it in the format you can read also nowadays. So they have a couple of really interesting emulations that you can start. So here are some of the services we are offered. So you can configure additional partner system via JSON. And we can check fixity between the different systems with upload, download, transfer. And metadata is added via JSON, and the transfer happens in Bagged format. It's like a zip file with some more features. You can enhance keywords. You can check the availability for file formats, the tools in Easy. You can check fairness of research objects. And this little spreadsheet shows a little bit which are already connected and which services are already available. To integrate new targets, it's really well described in our documentation. So step by step, which kind of JSON files need to be filled and which kind of services you need to connect to the PressQt API. But to be able also to show it, and that because the services are normally in the background, that's the idea. Users don't see them, but they can use their systems they are working with, like for example in Hub 0. They're not going to another user interface, but they stay in Hub 0 and they can get the functionality to enhance keywords via PressQt. But we have also, for demonstration purposes, created a small user interface. So this is one of the screenshots, but if I have time, but I don't think so, I can make a fast demo. And so this really shows you can connect to the different systems. You have the different services here, a download, upload, a transfer out from one system, and you can use these services. That was my talk. Thank you very much. Any questions?
Yes, thank you, Lola. Any questions?
I've got a question, if that's okay. Do you guys, part of making this successful is that people do a lot of upfront planning to put it into their projects. Do you provide sort of templates for researchers to say, here's our data preservation plan that you can fill this out and use PressQt, so that it makes it dead simple for them to take that thing and put it into their grant applications?
So we haven't done that yet, but I really like that idea. What we have, for example, in the library community with the libraries we are connected, they are aware of, and they are also, if they are contacted from their faculty on campus, so they spread the word on their campuses. But that would be a great way to have an additional feature to say this is now available and this can be integrated, because via the integration with Purate and D, we can be integrated quite easily also with Fedora 4, which is one of the used preservation systems in quite a few campuses. So that is, yeah, thanks very much. That is a great idea.
Yeah, and the reason I say this is because it's more than software and tooling, it's percent effort, right? And if you can give folks allocated percent effort recommendations, they can put that up front in their grant. I just,
Yeah.
Right, any other questions, anyone? If not, we're going to move on to the next speaker. If you have any more questions later on, Sandra's here, you can ask her in the chat. I'm sure she'll be happy to respond. All right, so the next talk is a tiered approach to software quality in National Laboratory Research Science, given by Miranda Munt and I think Wade Burgess. I think it's both of you presenting or just one?
It's just me.
Oh, just one. Okay, only Miranda Munt. She is from Sandia National Laboratories, and she's an early career research software engineer with a background in applied mathematics. She enjoys reading, baking, weightlifting, and hanging out with her orange creamsicle cats, Zuko and Leroy. And I think we introduced you yesterday already. That sounds very familiar.
Yes. I just want to make sure, can everybody see my screen?
Yes. Perfect. All right. Take it away.
All right, well, hello, everybody. As Yulia said, my name is Miranda Munt. My co-author is Wade Burgess for this presentation. We're part of a relatively new software engineering and research department at Sandia National Labs, which focuses on software engineering and research for scientific computation. You heard some presentations on Monday from several other members of our department as well. We aim to bring software engineering principles and best practices to scientific software projects in our center, including best practices relating to software quality. Oh, give me a minute. There we go. Now, software quality, in its general definition, measures how well a software is designed and how well that software conforms to that design. It's often described as the fitness for purpose for a piece of software. This definition also encompasses the major outcomes that come from proper software quality practices, all of the ilities, like usability, how effectively end users can use, learn, or control a system, maintainability, the ease with which you can repair, improve, and understand software code, stability, the ability of software application to continuously function over a long period of time, portability, the ability for an application to run on numerous platforms, and many of the other ilities, too many to list here, as well as some ility-free qualities like efficiency and better teaming procedures. Now, at Sandia National Labs, in our center, we do a lot of cutting-edge research. And in some of this research, even the concept of software quality is itself an open research question. Now, historically in our center as well, every project defines its own idea of software quality. That's up to the project lead to define it for that project. This has led for us to a lack of standardization. How can we really compare and define the quality of all of the projects within our center if projects are defining software quality in their own distinct way? This led to an effort by Wade and I to make a document outlining software quality best practices in a tiered approach. So it's more tailored to the size and intended use of each project, rather than a large blanket statement, and offers base quality guidelines to each software quality project. To start out this effort, we met with managers and project leads throughout our center to glean an idea of our center's values, and the results led to a 4-tiered software quality standardization document. The 4 tiers of our document are as follows. The first is the exploratory or proof of concept project. These projects are normally fairly new. They don't yet have a working piece of software and are in their exploratory phases. The next tier is the working prototype tier. The projects here have software that work on a cursory level. The software is not perfect, but it satisfies at least part of the intended purpose. The software has also been verified against peer-reviewed methods, if they happen to exist. The next tier is semi-productionized. The software here is more mature and stable, and generally has a wider range of use. The project itself may or may not have identified at least potential stakeholders and users, but do not have defined policies nor set up tools or processes to support regular releases. Which leads to our last tier, the productionized software project. This software is stable and mature. There are regular, clearly identified stakeholders and users, and the software is released on a somewhat regular cadence. Now, each one of these tiers has associated requirements and recommendations, with higher tiers having more rigorous requirements and lower tiers having less rigorous requirements. Let's talk about the requirements themselves. As the name implies, they're required. They're also collective. for all previous tier requirements are valid for later tiers. For example, at tier 1, which is the exploratory or proof of concept tier, projects are required to set up and use version control systems. This is also required as the project moves into every subsequent tier. In terms of recommendations, as the name implies again, they're only recommended. But many recommendations end up becoming requirements at a later tier. For example, at tier 3, which is semi-productionized, we recommend that a software team establish and document a user support process. This becomes a requirement, though, once the software moves to the productionized tier. As I mentioned before, the higher the tier, the more rigor is required for the project. Lower tiers focus more on data storage, cursory software requirements development, and functional testing. Higher tiers shift the focus to design and review, documentation, processes, and procedure. Now, many requirements and recommendations are based on the projected intended use of the software at the end of the project. We define 2 categories of intended use for our document. The first is to be used by domain expert software developers, and perhaps a very small set of colleagues, to answer research questions. The idea here being created by analysts for use by analysts, and generally staying internal to Sandia. The second category is the category to be shared with other users, internally or externally to Sandia, and by implication induces extra maintenance requirements. These are pieces of software that you intend to either market or productionize on a larger scale, or even potentially turn open source. Now, generally speaking, for the second phase, the intended use, we expect a software project to use more rigor in their software quality practices. As a result, our document suggests that projects that fall within that second intended use case implement the recommendations as well as their requirements as they make sense for the software project. Now, in terms of our document itself, it's only been in existence and in use for the past 5 months. We will be collecting data in the coming months and years about its efficacy in our group. And at its core, our process is a living organism. We will continue to update it as necessary to make sure that it is really a true process that fits into the life cycle of software within our center. Not another check marking activity, but something that's right-sized for all of us. And that's actually the end of what I have to say about this. So I will take questions now.
Great. Thank you, Miranda. Any questions? Anyone?
I have a question if no one else does.
Yes, go ahead.
I have to say, when you said that your requirements become more strenuous as the state of the project like moves to the higher tiers, that made me a little bit nervous to hear that. And I think it's because the concern that I would have is that adding or taking those recommendations and turning them into the requirements causes more work to have happen. Like, it's harder to add a requirement later in the process. Does that bear out in your experience, or is that just a kind of a fear-based reaction in the mind? Like, my first thought is I would want to try to get all of our requirements or even the recommendations locked down, particularly in terms of like processes and tools, as soon as possible, so that there isn't overhead adding a new requirement.
That's a really good question. It was something that we were worried about as well in working through and creating this document. But please excuse me, I have a cough. Something that we tried to think about in the process of creating these recommendations and requirements is putting them in at the time when they would naturally occur anyway. So, you know, you're not going to try to make user documentation when you're still in an exploratory or proof of concept stage, because, you know, your code doesn't even work yet. How do you use it if it doesn't work? Now, at the point where you might have a user, well, then it makes sense to start incorporating it. So by way of saying that our requirements get more strict, what it really means is they become more, as in there's more things you have to do, sure, but it's the natural progression that we start to add on. So we expect, if you're going to be releasing it to users of course you should have user documentation. But this is us writing down and saying, okay, never have we actually made this guideline for you before that you should have user documentation, but maybe you should. That's kind of how we've approached it like that, is to try to do things naturally as opposed to putting something on them that they wouldn't have done anyway.
Okay, thanks. Yeah, no, that makes sense.
All right. So Heidi wants to know if the document can be shared.
We have not put it through the review and approval process, but I can address that with my management and see if it is possible for us to do that.
Charles would like to know how domain scientists responded to this document.
That's a really good question. So I mentioned at the beginning of the project, the very first thing that Wade and I did was meet with all of the different management within all of the different groups to try to get an idea of what their values are. Because the last thing that we wanted to do was introduce another standardization that felt to people as if we were forcing them to do something. To an extent, of course, there's still going to be that kind of cultural shift that we have to fight against, where people are frustrated because, oh, there's another requirement, and they're worried about being able to make it work. Fortunately, something that we've done, though, is as a department, we put together a lot of resources that are in an appendix on our document that help people with these different stages, as well as making ourselves as a department available for people to have consultations, to ask questions about, well, what would it mean to do, this kind of functional testing, or what do you mean when you say this, to make it easier and more approachable for all of our different groups and different projects. So for the most part, we haven't gotten an awful response to it, but like I mentioned, it's a living and breathing document. So we're still trying to adjust it as necessary.
Great, thank you. Seems like Caleb and Ian have similar questions / comments. Ian is asking if this document is meant as justification for external partners or guidelines for internal teams.
I'm sorry, can you ask the question again? It cut out a little bit.
Ian is wondering if this document is meant as justification for external partners or guidelines for internal teams.
It's more meant as guidelines for internal teams. Something that I didn't mention is that when we created this, we were also keeping in mind the fact that some projects in our center already have software quality processes that they are required to follow by sort of their external funding resources or their people who are in charge of their projects themselves. So this is really only meant for those projects that don't have some sort of guidelines already imposed on them, either by a funding source or an external collaborator. It's meant really as a standardization baseline so that our project leads aren't just kind of all defining software quality based on their own standards or their own values. It's an attempt to try to find the center's entire baseline of standardization and quality.
All right. Elaine is asking, how does your SQ approach map to other efforts in the literature?
That is a really good question. I do not know the answer to it. The most that we've done is we've done a mapping of how our approach matches up with the corporate Sandia guidelines that exist. So we haven't done anything that maps it to the external literature yet because it's been meant for an internal, but I think that that's a really good idea as a next step for us.
Great, thank you. Does anyone else have any questions? No? All right, then thank you very much, Miranda. Very interesting talk. And we're going to move on to Angel Pizarro and Christian Kniep. I think Angel is the one presenting, right? Is that right?
Yes. Let me share screen. Go ahead.
Share your slide. He'll be talking about strategies for containerizing applications for use in HPC. And he is from Amazon Web Services. And he is a principal developer advocate for HPC at AWS with a background and focus on large-scale genomics and life sciences. His pandemic hobby has been to hack multiple air fryers of increasing wattage to roast coffee in the backyard. And so far, there have been no significant electrical fires. Hooray. hope it stays that way.
Yeah. Sorry, I'm trying to share screen. I have to quit Zoom because of macOS's security model. Let me just quit and come back in. Hold on a second.
Right. Hopefully that'll not take very long. Okay, we seem to have a lot of issues with operating system, new computers, and and the like in this workshop. All right, that looks good.
Okay, thank you. Sorry for that little snafu. It has to do with corporate not allowing Zoom. We have our own thing, and I just had to install it this morning. Okay, so strategies for containerization applications for use in HPC. This talk, I just want to say and qualify that I'm more of a messenger than I am a subject matter expert on containerization in HPC. That's Christian, but currently he's on a boat. So I am filling in for him and trying to do justice to the material. Okay, so next slide. So just a quick review of what I'm going to be covering today. I'm going to talk about some containerization issues for HPC, specifically how to handle accelerators and shared storage. What are the issues around there? Some notes on application packaging and portability of workflows. And there's going to be some resources links at the end of the slide. I'll share a link to the slides to the conference organizers so that they can get it. But not covered, since it's such a short amount of time, as container basics or anything really deep in containers. There's not enough time. There's a large body of work out there. And I'm not going to cover all possible tools that are used in HPC for containers either. I'm going to use a few examples and rely that you can translate from what I'm speaking about to the technologies that are used in your applications and places. So challenges for high performance containers. I'm going to take a quick historical view of what happens for containers with a view of ML. It started out simple, like all things do, where you have a containerized application that might have a bit of storage volumes, but these things are really well contained in and of themselves. And it's really fit the paradigm of like build it, ship it to some other environment and run it as is. That's where containers really hit a nerve within the modern application deployment and web services field, and it extended back to other fields as folks saw that it was useful for things like machine learning. So a typical simple container would have TensorFlow as a dependency application. It would have your scripts and your data all in one container that you're able to run and mount. But as soon as you start thinking about machine learning, you start thinking, well, we need more than just what's available in the CPU of a machine in the container runtime. We need specialized resources and accelerators like GPU. So NVIDIA quickly forked the Docker project. That was the precursor to most container technologies that live today. And added in a device pass-through layer that they then submitted back into Docker, and hence the rest of the container ecosystem. This ham bone is a big old GPU. Still, though, when you think about it, the application packaging and the sophistication of this container, this containerized application is still fairly low. You're still looking at data that's isolated. You're looking at permissions that are isolated, and everything is within the boundaries of what you would consider "quote unquote" safe. And then you get to shared storage, right? And specifically things that might have clashes. And this is really where the FUD really kept containers as a technology from being adopted faster within HPC land, is that the underlying assumptions of how you build, deploy, and run containers in other application spaces completely broke when you have shared resources. And in particular, you can mount the home but the thing that is running, the container engine that is running these containers has elevated privileges, and if you're not careful, you can stomp all over everybody's data. And it also has things that reach outside of the kernel space, right? So you have specialized interfaces for networking that have their own software stack that completely bypass the kernel. You're no longer in a space where the assumptions of a container are being met by the runtime needs of a community, also known as what we actually do in HPC, right? So that's how we got to where we are today. These are the challenges for containers in high performance computing, and there's been several efforts that have tried, excuse me, that have tried to overcome these challenges. This is one of them. I'm wondering, I don't know if you can see up at the top of my screen, but it says Saris. Saris is a container engine that relies on the Open Container Alliance initiative runtime, RunC. This was donated by Docker to the broader community. And it, as part of its build process and run process, it addresses a lot of the shortcomings with what was traditionally a container deployment and runtime strategy for HPC. And it does this by something that I'll call attention to here on the right side of the screen, OCI hooks. So what are OCI hooks? They're basically a standard coming from the Open Container Initiative that specifies points within the life cycle of bootstrapping and running a container that you can provide extra functionality to either override what's in the container or add more container functionality. And it has a few different stages. Before you start, the pre-start stage, when you're creating the container, starting the container, post-stop. I'm not going to get too deep into the details, but essentially there are places before the actual application, before the container starts loading itself, places before the application starts running, places after whatever code is in the executed within the container stops running, and right after you have shut down the running container process, right? So lots of hooks and you can do different things across there. Some examples coming from the CSCS, Swiss Supercomputing Center, that were the developers of Saris, are things like being able to mount and not just the device, but the device drivers for GPU support, hooks for MPI based libraries, being able to update in place the glibc within a containers host to ensure that, basically that the underlying OS's libraries are compatible with what's going to be run in the container, because those two things might not match exactly. And then some other functionality, right? So you can see how hooks into the process are useful. Other container runtimes don't actually use OCI hooks. They do it within the framework itself, which is fine. We're just sort of opinionated in this respect, that we think that OCI hooks, whether it's Saris or other container engines, they really should adopt this standard, because it's proven, A, that it works, and B, that if it does work, you're able to utilize the tooling coming from a much bigger software development ecosystem, and much better supported, quite frankly, than single projects. So here's an example of GPU pass-through. The things that I'll call out is the stages. So pre-start stage, always do this. And what I want you to do is mount into the container these libraries for running NVIDIA, right, which is great. Here's another one for MPI. Again, I'm not really going to go into it, but it alters environment variables to be able to do what it needs to do, again, in the pre-start stage. So in the context of how Saris runs, right, one, you're in the user context. You don't have elevated privileges when you run a container command. This up here, if you've never seen a container engine start a container, it basically says container engine. I want you to run the Alpine latest container image, pull it down if you need to, and then I want you to tell it the command of sleep 30. So you get a fork execution of the run C library, which itself starts the command that you gave it to the container. So looking back at our complexity sort of things that are going back here and whether this model works, and we see that it's true when you add GPU or specialized devices that need drivers coming from the kernel and the underlying OS, OCI hooks are available to you. It does the right thing within the user context to be able to have shared storage and make sure that those permissions are available. Those are not part of OCI hooks. That's actually within SARS, and it's usually handled within other container runtime engines for HPC, like Singularity or Charlie Cloud. But when we get to specialized, out of band kernel operations, OCI hooks do solve it for you here in a standard compliant way. So we think it's a nice system. Some sort of thoughts on what's happening with OCI hooks. The nice thing about this is that you can decide these things based on where the container is run to, specific to what is available to the host. And the thing that it's interacting with, like for instance, here's a typo, sorry about that, Slurm. So there are examples in the SARS repository for all of these up here. We think that we can extend this to some other interesting things, like for instance, data staging, whether this is coming from an external resource like our object storage S3, or if you're staging between some shared storage to local scratch space on a node. We think that these things are probably possible to do within OCI hooks. And last but not least, debug performance tracing of running container applications. We don't have an example out there in the wild of this, but I don't see if you can start up a process within a container that allows SSH sessions to call to each other. You can certainly start injecting some interesting traceability code within there. It's just nobody has gone through and actually done it yet. All right, changing topics a little bit away from applications. Once you have applications, what do we recommend as part of packaging an application? I personally think, and this is me, you should really rely on package management systems outside of any single container engine's tooling, either SPAC or Conda or what have you, to define what is the application, its dependencies, its shared libraries, and put that all in a user installable package. So again, we're big fans of SPAC. We're going to start working a lot more with SPAC in the meantime, and then use those sort of ready to run and ready to install packages to define multiple targets for deployment, whether that's Docker in the broader ecosystem, Singularity, SARS are both have SPAC has both ways to export to these on container runtimes, or you can go from Docker into user space container runtimes, or install packages, and then handle runtime and deployment things as you normally would with a workstation. This would be something like SPAC itself. So you're completely bypassing containers at that point. For cloud architectures, you're going to be bypassing other things and dealing with how clouds do it, depending on the service. And with HPC clusters, Vanessa gave a great talk yesterday on leveraging Singularity's a package that uses Singularity modules to put them and load them like they would user modules, which I thought was really clever. So if you haven't seen the video, hopefully there are videos, and go see Vanessa's talk from yesterday. It was really, really good. I'm running out of time. Workflows. So now you have applications, you have containerized applications. Now you really have to think about portability. Again, this is an opinion on our part, but we think as an RSC, you should actually focus and recommend workflow systems, whether that's SnakeMake, Nextflow, Apache Airflow. We could care less. But what we think is important, though, is that these workflow systems, the things that make them useful, is defining the runtime parameters as configurable. So things like, is this going to be a container or a local application? And then defining on where does my data live? within a runtime configuration constraint. So if your workflow language or framework doesn't support that, we think that's a big miss, because that allows you to take that portable workflow and send it to, dev and test and small runs versus really big schedulers, whether that's a cloud or whether that's your local resources. This is examples taken from the Nextflow team. So like I said, there's a bunch of resources. There's a much larger talk about containers from FOSDEM this year. You can watch here. That was Christian. This is where he is right now, the bastard. And we have some more presentations and workshops from previous ISCs. That's my last slide, so I'll take questions if I have it, but if there's not enough time, I understand.
Great, thank you, Angel. I think we have time for one question. Does someone have a question? Have a question? Anyone? If not, I'm sure Angel will be around. If you have more questions, you can ask them in the chat.
Great, thank you.
Thank you very much. All right, that gets us to the last talk for today and for this workshop. And I hope Michael is back. Yes, there he is, I think.
I'm here.
Yeah, great. So the last talk is titled Sustainability as a Key Enabler for RSE Path Forward, presented by Michael Sentner.
Yeah.
And he is from San Diego Supercomputer Center. And he once was about to start an argument with a guy who cut in front of him in line until he saw that the guy was Ted Nugent, and he realized he would lose the argument badly. So take it away.
Okay, I'm going to, I have a pre-recorded video. I'm going to share that and then have time for questions, hopefully, if anybody has any. Let me know if you can't hear it. I'll start it now. Hello, everyone. My name is Mike Zentner, and the Director for Sustainable Scientific Software at the San Diego Supercomputer Center. And today I'm going to talk to you about paths forward for research software engineers in the context of working on sustainable projects and how the role of sustainability can really enable those paths forward. And when we think about a path forward, we typically think in terms of career paths, either taking a technical or a more managerial path forward. But I'd like to simplify this by not talking in terms of professional career paths, but using the metaphor of a day in the life of a fish, or maybe a fish life cycle, to describe the problems we have as we try to define paths forward. Nearly all of the projects we work on are grant funded, and let's think about that funding as a fishbowl. The larger it is, the more funding we have. When we first get started, we really thrive. We have a lot of funding. Then the funding starts to shrink after a few years and we question whether we're thriving. Then it shrinks even more, and sometimes at the end of the project we wonder what even happened, to the point where suddenly we feel like we have to jump. And it's this jump that really is what causes problems with our advancement with a path forward. And we'd like to believe that one opportunity leads to the next and it allows us a smooth path of growth. But in reality, that's not the way the system works. In reality, there's lots of grants out there doing all kinds of different things. Eventually those grants end, a new pile of funding becomes available from funding agencies. PIs circle around that funding, they propose things, a bunch of new grants get awarded, and the process repeats itself over and over again. And as a result, we don't personally make progress as far as advancement goes. From an individual standpoint, each one of these jumps means a change. And we have to ask, how far is that jump that we need to make from where we are currently, either in terms of skills or responsibilities? Not only how far is that jump, but what does the environment on the other side look like? And are we even suited to be in that environment? Do we have to be able to modify ourselves to fit, either in small ways or even drastically to fit this new environment? So while what we might wish for is a large project with lots of funding that has many years for us to develop our own paths forward, this rarely happens. And so maybe we should ask ourselves, why are we even doing this? Well, I think we do this for a lot of good reasons. I've heard many of the following from talking to RSEs before: freedom of schedule. People like science, they want to do something positive for society. Many times I hear that there's always something new that happens every few months. Certainly there's lower deadline pressure in some respects. We get to have more intellectual participation than maybe we would in an industry job. We get to work with interesting people. And one thing I hear more often than probably I should is we don't want to or don't need to care about shareholder value. And that seems to be a big concern for some people. But I'm going to suggest that we actually do have to care about shareholder value. Now, we may need to think about shareholders differently than what you think when I say that word, but if we want to have a sustainable path forward, we need to care about shareholders in a certain respect. And I'll explain that in just a minute after I talk about sustainability. So let me start by saying what sustainability isn't. It isn't this picture that I showed you where we have a lot of funding and we grow over time. Instead, it's a project that funds itself as it gradually migrates over time and evolves, allowing for the participation of all different kinds of people during that growth. For that to become the case, one of the things that you do have to change as an RSE is you have to care about shareholder value. Now, what does this mean to you individually? Think about it in terms of how your project earns revenue. Although it might be crass to do so, let's view each project as a pile of funding. When you have one large project and that funding goes away, you have a problem. When you're working on two large projects and one of them goes away, you still have a problem. As you start to evolve and work on a couple of large projects and maybe a few smaller to mid-sized projects, you have a little bit less of a problem. And then if you can pad that with on the order of 10 or 20 even smaller projects that are very easy to execute, you have much less of a problem and you have a more robust revenue stream. So you might be saying, I'm a software developer. Why is he talking to me about revenue streams and different project revenues? Well, the reality is, if you want the kind of environment that I described and strong paths forward, you have to care about this to some degree. In a sense, you are one of the shareholders in the project. So yes, revenue composition is important to you. And if you want to be on a team of 15 to 20 people, the kind of project revenue stream or composition you need is something like I've shown here on this slide. But it also means there are things you're going to have to do in support of the people who manage that revenue stream. And some of these things may not be what you envisioned doing when you started the job, and they may not even be things you're very comfortable with, but they're essential for the kind of environment that provides a path forward. One of those first uncomfortable things is somebody has to be a salesperson. And that may not be you, it may be you, but regardless of who it is, you're probably going to get called in to support that activity and do presentations and answer technical questions and things that divert your attention from software development. But let's put the positive spin on that. The positive part of this is you'll never get a better view of the voice of the customer than you will engaging in the process of selling your product. And every software developer should have some visibility into the views of the customer. Another consequence of this is you'll most likely work in what looks more like a matrix organization, where you'll have multiple responsibilities across multiple projects, maybe managed by multiple project managers. It may feel at times like you have more than one boss. And of course, having these multiple responsibilities does bring up the topic of context switching. A lot of people doing software development don't like to do context switching, but it becomes a necessity when you're involved in a larger organization like this. And remember, these are sacrifices that we have to make if we want a path forward under this kind of model. And the last thing I'd say is to make all this work, there are probably going to be some things you have to do in terms of reporting that you currently don't do. In particular, you might have to log time against certain projects that are billed by the hour to earn revenue. All of that may sound a bit negative, but the true positive that come out of this are all of these things. You still get to see many sciences, but you get to work on a common core that stays over time. You do have a progression path, both technically and in management. We've had people on the team who've joined us as students who've grown into managers. We've had people on the team for more than 15 years in as little as a couple of months. You can't have the same employer for more than 5 years. Many times we feel like when we move from one grant to another, we take 2 steps forward but 1 step back. You don't have this issue anymore. What might be most valuable is you get to build lasting relationships, both with your coworkers as well as the clients you serve, and that can be very rewarding. I did say earlier that you had to care about shareholder value. Now, who are those shareholders? Everybody to whom you provide value. They can be your university, the clients you serve, they can be the open source community that you work with, But ultimately, the biggest shareholder in the whole process is you. You're the one providing value to yourself through creating an environment or helping to create an environment where you have these paths for advancement. So basically, it isn't anybody that you aren't already serving. It's just thinking about how you're serving them a little bit differently. So where are we going next from here? As part of the Science Gateway Community Institute, which is another project at SDSC that I lead, we're working on a multi-institution collaborative group between San Diego Supercomputer, the Indiana University Cyber Infrastructure Research Center, and Texas Advanced Computing Center to create a larger virtual team around a common infrastructure that spreads this model not just within an institution, but across multiple institutions. As to whether that works out, it's a huge cultural shift. There are many things that we may need to change going forward in terms of our team dynamics across institutions, but it's a worthy experiment, and hopefully I'll get a chance to report on it in the future. I'd like to close by saying sometimes as a path forward, we want many of the benefits that we might think of corporate careers having, but not always do we want to make the sacrifices. And I think what I'm talking about here is a happy in-between where we do have to make some of those sacrifices, but we do have significant paths forward for research software engineers that really can have a lasting impact beyond just single research projects, really working on core infrastructures that have sustainability plans. And I hope you see that the idea of project sustainability can be a real contributor toward having paths forward for research software engineers. Thank you.
Great, thank you. Questions for Michael? Anyone?
I have a question. So, Mike, so this is first planned, for example, let's say this model for the 3 institutions. And let's say there would be now a research software engineer who knows, oh, I would like to contribute, but I'm at a different institution at the moment, but could they join in the model without that there's an official partnership with something like that? I know it makes it more complicated, but could that be an open model to let people join from other universities?
Well, I think ultimately that's what we hope comes out of this. Initially, with the 3 of us, we're going to have probably enough really interesting collaboration issues that we haven't addressed in the past to get over. But I think once we get into the mix of it as it's starting to work, that's what we'd really like to see happen, yes.
Thanks. All right, anyone else? Any questions? If not, then we'll head into the break. All right, well, for everyone who is still here, thank you to everyone, to all the presenters and all the participants. It was a great workshop, I thought. I hope everybody else thought the same. The talk recordings will be made available soon, hopefully via our YouTube channel. We'll try to not let too much time pass till they will be available. So if you missed any talks, or if you want to watch them again because they were so great, they should be on YouTube. And I'm pretty sure we recorded all the talks. There will be another community call on June 10th. So join us in, 2 weeks for another community event. We will have our AGM meeting in December, which will be announced at some point when we have planned that a little better. Also, in case you were wondering, there is still an international RSE survey planned for an international RSE survey. It's just a little bit delayed, but it will be coming out. So watch out for that and respond if you have the time. There will also be an International RSE Day on October 14th. There will also be, as we have more information, they will make it available to everybody. And that will be around the globe, I believe, at least where there are RSE initiatives. Hopefully they will all participate. Oh, here we go. If you want to get more involved, there is the book club. If you want to, I think that the first meeting last Tuesday. I'm not sure if there, I'm sure there will be another one. I don't know when it is, but it will be made available. It will be made known. Join the channel if you want to get more involved in anything or want more information or want to talk to someone of the people who are actually in the book club. There's also the diversity, equity, and inclusion speaker series, which will likely to be the next event. Will likely be in June, with someone from the National Center for Women and Information Technology. The DI wants to make. We want to make the DI part of the US-RSE mission, and they are asking for comments by the community on the mission statement. See the DEI discussion channel for details for that. And last but not least, we have a survey for everybody to fill out about this workshop. So please go there, fill it out. It should only take a minute. It's not many questions, but let us know what went well, what didn't went well, what we could make better. If you want to help out for future events, let us know. And that's pretty much it. Thank you, everybody. It was great. And it wouldn't have been what it was without you, with all the presenters and all the attendees and all the speakers. Sandra, do you have anything else you want to say? Or Ian or someone else?
No, thank you. I think you said everything. Yeah, thank everyone again. That was really great. And as Julia already mentioned, the presenters, the participants, yeah, reviewers, the submitters. So, and thank you for lively discussions. That was really, I think it was a great event.
Yeah, so thanks, Sandra. Thanks, Julia, for pulling this together. I know it was a lot of work on top of your real jobs. Also, maybe I'll make a plea for filling out the form. You know, US-RSE is an organization for the community, so we really want to focus our efforts on things that people are interested in, want to attend. This is an opportunity to shape the direction of future events like this. If they're valuable, what's valuable? If there are things that could be better, please let us know. We do take those things pretty seriously. And if you're willing to help out in the future, this is we can almost call it a second annual workshop. So it's looking like we'll do more. So please give us your feedback. We'll really want to see it.